Hello everybody, welcome to my class. We are going to be addressing the power plant, specifically turbine engines, and I'm going to give you an introduction on the turbine engines. First, who's this? My name is Milan Days. I was born in Slovakia. I lived in South Africa. You can talk to me, Milan, at preciseconsulting.co.za. I feel aviation is awesome. I hope you do too. During our studies, let us consider the Pareto principle, where 20% of the effort gives you 80% of the results. The understanding, I believe, is the 20% effort. If we understand already, we gained 80% of the results of this subject. The extra effort that you put in will be to ensure that your error margin is lower, and you, of course, it would be best to know more than just 80% of the content. A great man said, education is not the learning of facts, but the training of the mind to think. Let us think during this class. Let us think about how these engines work, and let us consider the components within this. Operators love these engines. Why? Because they're very, very efficient. They are great for high-speed applications. They produce a massive amount of thrust and a massive amount of power. Their maintenance schedule is much lower than for the piston engines. The vibration is a lot less, and the power-to-mass ratio is immense for these engines. Typically, you're looking at an unlimited amount of thrust by these engines. There's different types of the turbine engines which have common features. Okay? There's the pure turbojet. Turbojet. There's the low bypass ratio turbofan. There's the high bypass ratio turbofan. There's the turboprop and the turbo shaft. You'll see that each of these engines, types of construction, has got one thing in common here. Turbo. It's got a turbine in it. And it's not just a jet engine, it's a turbine engine. Right. The difference with the turbojet, it does not have a fan in front of the compressor here. Massive amount of noise gets produced in all this. Very, very fast. There's the low bypass ratio. You can see that the diameter is much smaller than the high bypass ratio. Here, a massive amount of air gets ducted around the core of the engine compared to this low bypass ratio, where only a small amount of air gets bypassed around the core of the engine. On the turboprop, the turbine drives a reduction gearbox, and that reduction gearbox is connected to a normal propeller. This is for low speed applications. It's very, very efficient, but at much lower speed. These are high speed aircraft. The turbo shaft, there's no fan in front of this engine. There's just a gearbox, and that is where the power gets taken off. The turbine drives the gearbox. The turbine also drives the compressor, but it also drives the gearbox. And that is the main difference between the turbo shaft and the turboprop. Here, there's a propeller directly connected to the turbo, to the gearbox. Here, not necessarily. It works. Simply. It's very, very simple operation. It sucks. It sucks the air in. It squeezes it here. It compresses it by means of a compressor. There's a combustion chamber here. It combusts the gases and the fuel. Here's the turbine. By reaction of the expanding gases, the high-speed expanding gases, it will turn this turbine. And the exhaust gases gets exhausted out the back, producing a massive amount of thrust there. The difference between the reciprocating engine here and the turbo jet, the turbine engine, is that the piston engine here follows the Otto cycle. This follows the Brayton cycle. Here are separate induction, compression, combustion and exhaust stages within one revolution. Here, the intake, the suck, the compress, the burn and the exhaust all happen at the same time. For every revolution, it's continuous. The difference between the piston and the turbine is that the piston, the combustion, is at a constant volume. The turbine, the combustion, is at a constant pressure. Okay, so simply all it needs to do is produce a propulsive force known as thrust. And how does it do it? It accelerates a massive air or gas rearwards. This way, massive gas mass gets accelerated rearwards by reaction is thrust forwards. Quite simple. It follows the Newton's third law. By reaction produces thrust. For every action, there's an equal and opposite reaction. Action, reaction. Okay, so here again, just the cutaway view of the turbojet. It is a cylinder. It's cylindrical in shape. It has got various ducts, divergent, convergent, divergent again, and convergent again to the back. Why? As you know, it needs to increase the static pressure at certain stages. It needs to increase velocity of gases at certain stages. Right here, the compressor consists of a series of aerofoils that are connected to a disc here. Right? This is an axial type compressor, and it compresses the gas throughout. It's got multiple stages of compressor where there's a stator and a rotor. A stator and a rotor is one stage. Each one produces a very small amount of pressure, but many together will produce a massive amount of pressure. The combustion chamber here, what happens is that high compressed gas goes into the combustion chamber, fuel gets added, there's ignition, there's a massive expansion of gases through the turbines, which spins this turbine. This turbine is directly connected with the shaft to the compressor. So as the gases force this turbine to spin, it forces the compressor to spin. By forcing the compressor to spin, it draws in more air. It compresses more air. And that is how the high compression gets produced and a high thrust gets produced out of these engines. Okay, so here we go deeper into the subject. But first, let's take a break. Let's discuss it. Let's divulge what we know. Let's digest what we understand. Now, thank you very much for listening. Thank you.